All right, got the chat up, got everything else up. This is actually going to be short. Like short, short, short. Let's see. I need this and this, and that can go away. Don't need that anymore. All right, we are in module number 10, mobile app investigations. There's actually not a lot of information in this chapter, so this lecture will be short. And the reason why is because this is a introduction into mobile app investigations. It is really a world in and of itself. There's a whole lot to dig into for mobile apps, and this chapter really just introduces that realm to you. But if you are interested in mobile app investigations, like I said, there is an entire world of that you could just dive in. There's an entire industry around that. There are two forms of analysis for mobile applications. The first one is static. For example, this picture is of Tinder, which is going to get a hit twice in this lecture. During app installations, a typical SQLite database will be created. This is a relational database comprised of tables that may or may not be encrypted with users' contacts, communication with contacts, etc. These databases contain extraordinary amount of personally identifiable information and can put an individual at risk for social engineering. These can also be subpoenaed by a third-party service for evidence. So SQLite is the preferred storage for mobile apps. This picture, like I said, is what you see with Tinder. Databases can have anywhere from 5 to 100 tables. Within each SQLite file, you'll find all kinds of other files like database, JPEG, etc. In iOS, the library folder is where you will find all the important user data, like the cache, the cookies. In preferences, you may find usernames and passwords stored in plain text. We can see the name of the app, com.cartify.tinder, which is referred as the bundle ID, the uniform type identifier made of alphanumeric characters to identify an app. So one way of static review is literally looking at the files that exist for that certain application. There is also code review. In Android, there is a manifest file called Android manifest.xml, which shows the permissions associated with a particular app, such as the course or find location, network providers, GPS, camera, etc. This is an example from WhatsApp. You see all the permissions that WhatsApp version 2.12.550 is asking for. Typically, the way that you would do this in Android is you would use a tool called dex2jar that would turn an Android application into Java, which then you could open up and read the source code. And in that way, you could do static analysis of an app. Now, the big difference between static and dynamic is static is we're not actually running the application. We're looking at the files that exist when it's created, or we're looking at the code itself, but we're not running it. Dynamic is exactly the opposite, is where you're running the app in things like an emulator or on a device that you have things like Wireshark connected to, or process manager, things that you can read what's happening in CPU and memory and in the network and see what it's doing, see its behavior, see its reactions, that kind of stuff. All of that is dynamic analysis. Here's an example with Tinder. Tinder allows deep linking, a way to connect social media accounts within the app. Using a tool called RobText, you can map out the domains associated with Tinder. By doing this, an investigator can determine where an app is being stored and determine jurisdiction. You can find out where that data is being stored and create the appropriate documentation to get jurisdiction as to a certain place. So for example, in the third picture, we see US East, Amazon AWS. So if we needed to get that information, we're not just going to ask Amazon in general. We're going to go specifically to where the US East 1 data center is. And this you would find, again, mapping out the app and getting that information. An examination of the SQLite databases of Tinder will show you the location of other Tinder users in close proximity. Scary enough, it is possible to obtain more precise information about a user's location within the vicinity because it is stored in those databases. This can be a security problem for other users. This could also be useful information when investigating investigating something. Other applications will have similar information, some easy to read and unencrypted, and others will be a little harder to dig into. But again, this is just a high-level overview of mobile app investigation, because this can get deep really fast. And this class is really just built to show you around and really get you into the digital forensics, not necessarily mobile, but just covering it so you have an idea that this world exists, and if this sparks your interest, go for it, because you won't be without a job doing this stuff. Now, I want to remind you that in the modules, I'm working on module 12 right now. We no longer have any labs within them. Now here's 10 and 11. There's no labs to do because all the labs are down here in the cases section. The cases overview will take you to the same link that now has all the files you need. Most of the cases are now available. I haven't made the National Gallery DC attack files or the patents one available. I might actually take out the patents case and just leave Lone Wolf and DC as the two big cases. But you do have Lone Wolf available, and you have all of the small cases available. Again, I highly, highly encourage you to work together I don't necessarily think it's possible to complete all these cases in the last couple of weeks just by yourself. I think it's best to work together. That is what we do in the digital forensics realm. People work together to solve these crimes, solve these cases. So again, I suggest one student pull up a server, install Autopsy, and make that the central machine, and others can VPN into that system so that everybody has their own Autopsy running, but connected to a central location. I mean, Lone Wolf, for example, the file in and of itself is like 32 gigabytes, and then when you unzip the contents, it's another 40 gigs, I think. It's huge. You know, so yeah, I think it's just easier if everybody works together, shares one common storage location. To me, that's what I would do. So I encourage you to do that, but you don't have to follow my encouragement. You can totally do it on your own. Either way, all that you're doing is submitting a report. Picture's not working. All the pictures are working. You're submitting a PDF. And for Cabrillo College students, the due date on them is all the same due until date for all of the cases. So it is possible to complete this class before week 16. Because as you see, I have 4 more lectures, and then it's just cases to the end. So like I said, feel free to work together. That is not a form of cheating in this course. It's all good. I'm okay with it. Let me know if you have any questions. Do my best to provide you with enough info without giving any answers away. But have fun. Are there any questions before I end the stream? Like I said, today was going to be short. Yes, I still have credits. If you need GCP credits, just ask away and I will get those to you. All right, see you.